is in here? Okay, alcohol, okay, and what kind of gas? CO2, right. So our Saccharomyces cerevisiae is going to take its NADH, the electrons that are there, going to transfer them to pyruvate. The reaction of reducing the pyruvate is what then makes our carbon dioxide and ethanol, if you're Saccharomyces cerevisiae. If you're a different microbe, you're going to be doing the same exact thing, but pyruvate might get reduced to something else. So there are all kinds of fermentation end products out there. Lactic acid, for instance, can be one of them. Butyrol, all isopropanol, all kinds of weird things that are out there. And you are going to see the results of some of that, because today we're setting up some fermentation tests where we're going to see if certain microbes can ferment things like lactose, glucose, and sucrose. And when they do, they're going to be producing acidic products that we'll be able to see a change in pH in those broths because of that. This is just what we talked about. So we have our glycolysis, which is the breakdown of glucose, the oxidation of glucose down to pyruvic acid. We get a net gain of 2 ATPs, and then the pyruvic acid gets reduced to a fermentation end product by NADH, because we need that NAD plus again for that redox step that's in glycolysis. I gave 2 examples. The one we talked about the most was the Saccharomyces cerevisiae, which is reducing the pyruvic acid to alcohol and carbon dioxide. So pyruvate is the electron acceptor, final electron acceptor in fermentation. But if there's some different microbe like Streptococcus lactis that's involved in making cheese, then lactic acid is going to be your fermentation end product. There are a whole host, like I said, of different fermentation end products. Here are examples of them, depending on what microorganism we have. They're all similar, though, in that they're all doing glycolysis and only getting the 2 ATPs. They're only getting the energy difference between the glucose they started out with and then whatever their waste product is. Later in the semester, you're going to find that some of these waste products of some of these microbes can be food for some other microbe. Like, for instance, ethanol can be used by some microbes, and actually some of these are ones that are bad ones in wine, because some microbes, like Acetobacter, use ethanol as its energy source, and it breaks down the ethanol to acetic acid, which is vinegar, and that's why sometimes wine turns bad, because of that other microbe that's in it. But fermentation, even though it's great if you're in a microbe where there's no oxygen, because you can make ATP, it's not that efficient, because there's a lot of energy left in glucose that the cell is not realizing, not being able to get. On Wednesday,